Okay, so now let's write down the Hamiltonian method that we will follow, okay? So this is where the Hamiltonian is defined as a function of r and r dot as t as a function of r dot plus u as a function of r. Does everybody understand what that means? T is a function of r dot means T will have what kind of terms? Velocity terms. And V will have what kind of terms? Position terms. Step number one. Number one. Form the Lagrangian, which is L as a function of T minus V. Step number two. Find generalized momenta for all coordinates in your system, which means you're going to find partial L over partial Q dot. What that means is you're just going to find partial L over partial V, MV, right? That's all it's saying. But we'll get to that. Number three, rewrite values from step 2 for Q dot in terms of momentum, which means what I'm asking you is to find Q dot as a function of Q and P as needed. Mostly it's going to be a function of P. Number 4, write the Hamiltonian in terms of momentum, P, I. And the expression for that is H as a function of Q and P will be given by Pi Qi dot, where I is what we're summing over, L, Q, and P, I and I. Step 5, re-express Hamiltonian in terms of momentas, which means H should be a function of only Pi. Number 6, substitute and solve Hamilton's canonical equations. Hamilton's canonical equations of motion. And they were how many? 2. So partial H over partial Pi equals Qi dot. And partial H over partial Qi gives you minus Pi dot. That's it. These are the 6 steps.